మీ ఇష్టం. Hello dear students, everybody, good afternoon. Welcome to Infinity Learn by Sri Chaitanya. Dear students, today's session is a very special session. This is all about graphs of trigonometric functions. In the earlier classes we have talked, we have discussed, we have defined what are trigonometric ratios, trigonometric functions, their domains and ranges. In this class I am going to highlight the very important part related to graphs of trigonometric functions. Right dear students, you know well the graph of a function talks almost the life history of the given function, isn't it? Because if you are comfortable, if you are able to trace the graph of a function, we can comment its domain, we can comment its range, we can answer certain questions based on number of solutions. In future in calculus we will see we can comment the continuity, differentiability, integrability of the function. Of course many questions are linked with graphs of trigonometric functions. So this is why my dear friends, in this class I am going to detail in a comfortable manner, we will go with a slow pace. I am going to explain how to draw the graphs of the 6 basic trigonometric functions. Right dear student, hope everybody is ready to start the class, shall we? Right, chalo. So by the way, you know, this is BS Math Faculty for IIT JEE at Infinity Learn by Sri Chaitanya. Right dear students, yeah. So what are we going to see in this class? The two things that we are going to highlight here are, I can say, yeah, the graphs of trigonometric functions we are going to highlight, followed by the domain and range of trigonometric functions. These two concepts I am going to highlight in this class. Right dear student, you know the very basic function, first trigonometric function is y is equal to sin x. When we have defined this by its definition, of course we have observed that the range the domain of this function is going to be r. We can give any angle as input, whereas its range is -1 to 1. So let us see this through graph. Okay, so I have taken x axis here, y axis here, this is the first step. Now the numbers on x axis better you take in terms of radians. I choose this number to be 0, say significant numbers I am taking pi by 2, pi, then 3 pi by 2, 2 pi, then 5 pi by 2, say 3 pi. So almost suppose I have taken to scale. So here also I take minus pi by 2, minus pi, like this. Now the number on y axis that I am taking is 1 and here it is -1. Now dear students, to draw the graph of any function we need to give some values for x and accordingly we get some values for y. We plot those points in xy plane. For example, for this function when x coordinate is 0, sin 0 you know it is 0, 0 0 is one of the points. Suppose if I give x the number pi by 6, sin pi by 6 you know 1 by 2, pi by 6 comma 1 by 2 is the second point. Likewise, if we give all the points, the graph that we are going to get here, you can see sin 0 is 0. Dear students, let me take some different color here. Okay, let me choose this color. And 0 to pi by 2 we are in first quadrant. Sine function, you know, sin 0 degrees is 0, sin 30 degrees is 1 by 2, sin 45 degrees 1 by root 2, sin 60 degrees root 3 by 2, sin 90 degrees is 1. You know these values. You can observe that sine values slowly increase and at pi by 2 you reach to the number 1. Am I correct? Now pi by 2 to pi, we are in second quadrant, sine is still positive. So, you just try to draw the graph of this, but it slowly decreases and comes to the number 0 when x is pi. So, this is the graph of sine function in the first quadrant and second quadrant. Now, from pi to 3 pi by 2, you just see, dear students, we are going to enter third quadrant. In third quadrant, sine function is negative. So, when we give the values of x in third quadrant, the values come from pi to here to at 3 pi by 2, sine takes minus 1, the minimum value. Now, 3 pi by 2, 2 pi, we are in fourth quadrant, still sine is negative, its value goes from minus 1 to 2 pi. 2 pi angle is almost 0 angle. So, we have completed one cycle. You see the graph of sine, it is a beautiful wave kind of, right. Now, again, you know, sine 360 degrees plus theta is sine theta. So, same portion is going to be repeated again at 5 pi by 2, 1, then again comes, the same portion continues. Even in the left side also, the same kind of part we are going to get at minus pi by 2, minus 1, at pi, this is the graph. So, friends, just what I have done is to draw the graph of y is equal to sin x. Step 1 is you take x axis, take y axis. On x axis, for convenience, the numbers I have taken in radians, preferably you take pi by 2, pi, 3 pi by 2, 2 pi, like that. On y axis, you take 1 minus 1, because you know sine maximum it takes 1, minimum minus 1. Of course, here also there will be 2, 3, 4 and all, I did not draw those. Now, you just plot this, you will get a smooth curve like this. So, what are the observations here from this graph, my dear students? So, sine graph, point number 1, it passes through origin. It is a smooth curve. Of course, even though you do not know mathematically what is continuous function, one can say that there is no break to the curve, it goes continuously, it is a continuous smooth curve. And from the graph you can say domain is all real values. The range means you have to see on y axis, when the graph is taken on y axis, the values covered are only minus 1 to 1. No portion of the graph is there above 1 and below minus 1. So, friends, from the graph of sine function, conclusion 1 is domain of this function is R, range is minus 1 to 1, then it is a continuous smooth curve, and I can say that, you see, we are going to answer few questions based on sin x curve also. Do remember, sine curve passes through origin, this is one important observation, right dear students. So, with this we have completed one curve, that is y is equal to sin x. I think you are clear with this, right. You see dear student, the same curve I have drawn here, you can see sine curve in a neat manner I have drawn. Earlier that was we have drawn with the hand, you see this curve I have taken the same plottings 0 to 4 pi I have taken, you see smooth curve sin x curve will be like this. Clear dear students. Now, what is the second function that we need to discuss? The second function is going to be, yes, come on, it is cosine function, that is cos function, right. You see, you know well with the definition of cos x, you can say the domain of this function is R, and even for this function range is minus 1 to 1, okay. Yeah. Now, how to plot its graph? Let us try first. Here also, for plotting, the numbers are on x axis I am going to take same like pi by 2, pi, like this, multiples of pi by 2, it is 0, say pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, 3 pi. Even the left of origin, I mean you can take minus pi by 2, minus pi, minus 3 pi by 2 like this. Even on y axis you take the numbers 1 minus 1. You see, plotting is just same like sin x curve. Now you try to draw the graph. Fine, okay. So to draw the graph, dear students, yeah, let me take this color. First function, sine function, okay, cos 0 is 1, my dear friends, cos 0 is 1, cos pi by 2 is 0, and moreover if you observe the values of cos function from the table what we have remembered, cos 0 is 1, cos pi by 6 is root 3 by 2, cos pi by 4 1 by root 2, cos pi by 3 is 1 by 2, cos 90 degrees is 0, slowly decreases. So, if you plot all those points, you can observe cos graph is a decreasing one in first quadrant. After this, in second quadrant, cos function is negative, you know well. So, here it decreases, cos pi becomes minus 1, this is the graph. In third quadrant, pi to 3 pi by 2, cos gradually increases, at 3 pi by 2 it becomes 0. 3 pi by 2 to 2 pi, in fourth quadrant cos is positive. So, cos 2 pi becomes 1. Yes friends. So, this is the journey of cos x from 0 to 2 pi. You see, same kind of sign, but some phase difference is there. If you continue the same, you can also say the rest of the part continues like this, in the same way it continues. Even you can also see the graph here like this. So, the graph is almost like sin x. If you push this cos x a bit to 90 degrees, it will be like sin x. But in fact, the major difference between these two is sine graph passes through origin, sin 0 is 0, whereas cos 0 is 1. Yes, that is the major difference. Unless otherwise, from the graph you can clearly say that, yeah, you can clearly say that the domain of this function, you see, clearly the domain goes to R, and the range of this function, you see, on y axis you have to see the range covers minus 1 to 1 only. Yes, it is also a smooth curve, it is also continuous curve, and of course one important observation is this graph will be symmetric about y axis, because if it continues like this, you fold about y axis, the graph matches because it is even function. Fine, we will have that discussion in some other time. So, this is the graph of cos x function, right. The same thing I am going to show in a neat diagram here. You see, this is the graph of cos x, my dear friends. You see, cos 0 degrees is 1, pi by 2 0, at pi minus 1, 3 pi by 2 0. This is the graph of cos x, dear students. So, we have discussed two basic trigonometric functions graphs, one is sin x, second is cos x. Similarities are both have the domain R, both have the range closed minus 1 to 1, both are smooth curves, both are continuous curves. At the same time, the difference is sin x graph passes through origin, whereas cos x function you just see slight difference, cos 0 is 1. That is the major difference, otherwise almost the same, isn't it, dear students? Right. Next, yeah, the very special function tan x. How to draw the graph of y is equal to tan x? Shall we, dear students? Shall we go to the next function? Okay, chalo. right. Y is equal to tan x is the third function, okay, right. Here, first of all, by definition, tan x is sin x by cos x. Even in the previous case, you can see y is equal to tan x, which is sin x by cos x. Point number 1, whenever cos x becomes 0, that means at the values of x where cos becomes 0, here denominator becomes 0, tan function is not defined. You just observe where cos becomes 0, you just see previous graph, you see cos function becomes 0 at pi by 2, again 3 pi by 2, 5 pi by 2, at every odd multiple of pi by 2, cos function becomes 0 even at minus pi by 2 and all. So, dear friends, from the domain, x can be given any real number except, yes, you see cos function becomes 0 at odd multiples of pi by 2, you just remove those odd multiples of pi by 2 from the domain. Now, this function is okay. This is why, dear friends, let me repeat, what is the domain of the tan x function? The tan x function is defined at all real number except where cos x becomes 0, that is except where x is odd multiple of pi by 2. Odd multiple of pi by 2 means pi by 2, 3 pi by 2, 5 pi by 2, like this, my dear friends. Now, let us try to draw the graph of this. Yes, please see, it is very interesting graph. So, same x axis, y axis, plot the numbers in radians like 0, pi by 2, pi, 3 pi by 2, 2 pi, the same way here also minus pi by 2, minus pi, minus 3 pi by 2, like this. Now, dear students, let me try to draw the graph by taking certain values for x in first quadrant first. Yeah, friends, tan 0 degrees is 0. Very interesting point. Tan pi by 4 is 1. Tan pi by 3, 60 degrees is just root 3, which is 1.7 something. Tan 70, 80 degrees also finite number. When you go to almost pi by 2, means at almost pi by 2, left of pi by 2, sin x will be almost 1, say 0.9999 something, by cos x will be almost positive 0, 0.000000 something. So, this number will be very big number. So, dear friends, for your reference, just let me draw some dotted line. This is not part of the graph, this is just a reference line. Let me draw, dear friends, tan graph, it grows slowly at pi by 4, 1, 60 degrees root 3, suddenly it goes to infinite, my dear friends, suddenly it goes to infinite. Yes. Yeah, let me draw clearly. Yeah, it increases slowly and goes to almost infinity, just left of pi by 2. 1 second. What is its behavior in second quadrant? At pi, tan becomes 0, undoubtedly second quadrant tan is negative, whereas when you come to this side, this will be negative at almost pi by 2 left side. You see, just you are taking pi by 2 right side, sine will be almost 1, positive 0.999, whereas cos will be almost 0, but negative 0, negative number. So, friend, this magnitude will be very big like infinity, but minus will be there, so it goes to minus infinity. So, that is the speciality in this particular graph, my dear students. Here, many students say, if I say what is tan pi by 2, many students confirms that they say infinity or not defined. It is not like that. The point is, at pi by 2, tan x is meaningless. it is not defined. Whereas, if it is almost pi by 2, almost pi by 2 means if it is just slightly less than pi by 2, it will be at plus infinity. Just right side of pi by 2, it will be at minus infinity. You see how tan x graph rapidly increases. You see, it is slow, it is very slow here, but at almost at 88 degrees and all, it rapidly goes to infinity. So, immediately it has fallen down to minus infinity. See. So, this is why in nature also rapid growth causes destruction. When a chimney is very hot, if you pour a bit of water spots, see what happened? Water droplets will break the glass, isn't it? So, in nature also, you just observe sudden change is always dangerous. You see, it has tried to grow suddenly, broken down, it has fallen down to minus infinity. Maybe a little philosophy I have added to the graph. The point is, my dear students, tan graph in first quadrant like this, its discussion at pi by 2 is interesting and important. Tan pi by 2 is not defined. Tan almost pi by 2 means do not say infinity. If it is quite left of infinity, I mean left of pi by 2, it is at infinity, right of pi by 2, it is at minus infinity. Whereas at pi by 2, the graph has no meaning, graph is not there, the graph is discontinuous. Now, you can continue the same discussion even here also. Yeah. So, this line is just for reference. Here third quadrant again like first quadrant itself, because tan pi plus x is tan x. So, then again you can continue the same portion of the graph, the same part will be continued like this, again like this. This is the graph of tan x, my dear students. From this, what can I say, dear student? What are the important points related to tan x function? Its domain is R except odd multiples of pi by 2, pi number 1. Within its domain, it is continuous. It is discontinuous at odd multiples of pi by 2. Its range, you see on y axis all values are covered, its range is R, right. So, these are the important points that you need to master at the graph of tan x function, my dear students. So, let me give the same graph in a neat manner. Yeah, this is the graph of tan x, dear students. Here you see minus pi by 2 to pi by 2, it will be like this. The same portion of graph continues. Of course, in the later stage we will define what is periodic function, what is its fundamental period. I can say this length pi is the fundamental period of this function, because the same portion of graph repeats in a regular intervals, right. So, I can say these are the important points related to the third trigonometric function. Okay, dear students, we have done sin x function, cos x function graph, tan x function graph. Now, coming to their reciprocals, right. Chalo. You see friends, cortex function, cotangent function, you know the graph, the definition of this is y is equal to cot x, which is nothing but cos x by sin x. Okay. Now, can you say its domain, my dear students? Yes, this is defined everywhere except where sin x becomes 0. When will sine function be 0, my dear students? Sine function becomes 0, you just see sine graph. Yes, 0, pi, 2 pi, 3 pi, 4 pi, that is at n pi, at every, you see the graph of sin x, let me recall, this is the graph of sin x, you see 0, pi, 2 pi, 3 pi, 4 pi, at all these numbers sine function is becoming 0, that means n pi. This is why its domain is all real numbers except x is equal to n pi, I can say, dear students. Okay. So, now, yeah, so come to try to draw the graph of this cot function. First step, x axis, y axis. Then the second step, plot the relevant angles on the axis. So, this is friends 0, pi by 2, pi, 3 pi by 2, 2 pi. In the same way, here also you can take minus pi by 2, minus pi, minus 3 pi by 2 and all. Now dear students, the interesting part here is cot 0 means cos 0 by sin 0, not defined. So, you cannot take 0 in its domain, but almost 0, right side of 0, cos becomes 1, sin is almost 0, the answer will be at almost infinity. It gradually decreases and at pi by 2 it becomes 0, cot pi by 2 is 0. In second quadrant, cot is negative, and at pi, dear students, just for reference I am taking a dotted line. So, the graph comes down like this. This is the graph of cot x in first and second quadrants. Now, cot pi plus x is cot x itself. So, the same graph, this is the dotted line for reference, the same graph continues. Yes, you can also see the same kind of graph even here also, my dear friends. Once you understand the definitions, you can draw the graph very easily, very easily. So, this is the graph of cot x, my dear friends. Simply observe the domain. Cortex function means cos x by sin x. Sin x becomes 0 at n pi. So, you just take the domain as r minus n pi, whereas the range you can see it is r, range is r. Point number 2, dear students. After this, I can say that this function is continuous in its domain, whereas discontinuous at n pi. Okay. So, from this graph I could answer domain, range as well as continuity, of course differentiability. Suppose if I say let me take the questions later, otherwise in the interval 0 to pi, how many solutions are there to the function cot x is equal to 1003, I said. Suppose this is the question. If you are aware of this, cot x graph 0 to pi is this, 1003 will be there, the graph cuts at only one point, you can say there will be one and only one solution. See, such questions we can see later in mains as well as advanced, which are very, very important model, which can be answered only with the help of graphs. So, this is why graphs are very, very important. Yeah, hi Sai Chandra, hello. Yeah, right, fine. Then next graph, dear student, you see here itself I have drawn Cortex graph. You see, you can have some reference. At 0, you see it is almost at infinity, 0 to pi the graph is like this, and pi to 2 pi the graph is like this. You can see the graph of Cortex, right. So, my dear students, so Cortex function. So, with this we have covered the graphs of 4 fundamental trigonometric functions: sin x, cos x, tan x and cot x, my dear friends. The next two left out functions are cosecant x and secant x, right. Let us take up those functions. You know well, cosecant x is defined like, we also call 1 by sin x, cosec function 1 by sin x. So, by definition you can observe the domain, sin becomes 0 at n pi. So, the domain is going to be r such minus x such that x is equal to n pi. We remove all multiples of n pi from the domain. That is one point. Range is the interesting point. You see, sin x values, you just let us try to draw the graph. You just plot our regular plotting 0, pi by 2, pi, 3 pi by 2, 2 pi, you can continue there, minus pi by 2, minus pi, minus 3 pi by 2 minus 2 pi. Now dear students, you just take the first quadrant at 0 almost right side, because at 0 the function is not defined, right. Now almost 0 at right side, 1 by sine 0 will be at plus infinity, dear students. At pi by 2, 1 by 1 becomes 1, suppose this is 1. It gradually decreases to 1, because friends, you know, sine takes the values from 0 to 1 whose reciprocals will be greater than or equal to 1. So, this is why cosecant graph will be there. In second quadrant, sine is still positive, so cosecant is also positive. So, it is increasing, no, here it will be sine will be decreasing, so it will be increasing. You can observe, just for reference I am taking some dotted line here. Yeah, it goes and again it goes to infinite, dear students. You see, sine used to be here, its reciprocals, because the numbers you take 0 to 1, the reciprocals will be 1 to infinity. This is why cosecant x graph you got like this. Okay. In the same way, in third and fourth quadrants, at 3 pi by 2 it is minus 1, and as the reciprocals of minus 1 to 0 are taken, the graph comes like this, friends. This is the graph of cosecant x from 0 to 2 pi. Cosecant 2 pi plus theta is cosecant x itself. That means the same portion continues in the same way. You see, if you take like this, here you will get this portion, then next this portion, like this you are going to get. This is the graph of cosecant x, friends. From this you can say the domain of this function is r minus n pi. Range you just observe, the graph covers the values from 1 to infinity on y axis, again minus infinity to minus 1, these values. No portion of the graph lies between minus 1 and 1. So, the range is important, friends, minus infinity to minus 1 union 1 to infinity is the range. Okay. Right. Now, dear students, you see, this is the graph of cosecant x in brief to see. You see, it is a clear graph. So, I have drawn a freehand drawing. So, this may not be to the scale, this is why I have taken up this diagram. You see, this is the graph of cosecant x. You see, exactly the same two portions will be getting repeated. You can also say it is periodic with an interval of 0 to 2 pi, because this portion repeats, right, my dear students? Fine. The next, now you can say the graph of secant x, it is not a big issue, because now you are habituated to draw the, hello Aman Verma sir, how are you? Yeah. Thank you very much. It is nice to see you here at our platform. Yes, sir. Fine. So, now you see, to plot this particular graph, dear friends, same like sine, cos, secant, cosecant, you can just put. Now, you can draw, I think, 0, pi by 2, pi, 3 pi by 2, 2 pi, in the same way minus pi by 2, minus pi, like this. By this time, dear students, I think you can draw the graph of secant x, because secant x domain, it's by definition it is 1 by cos x, 1 by cos x. You know, cos function is 0 at odd multiples of pi by 2, isn't it? So, the domain is all real numbers except odd multiple of pi by 2. Okay. Right. Now, so at pi by 2 it is not defined. One thing I can say, at 0 cos 0 1, so secant becomes 1. 0 to pi by 2, cos is in first quadrant, moves from 0 to 1, so 1 to 0, so its reciprocals move from 1 to infinity. You can imagine a dotted line here for reference. In second quadrant cos negative, so secant negative, its graph will be, it is -1, it will be like this. Now you can easily complete the rest of the portion. In the third quadrant secant x will be like this, again at odd multiples of pi by 2, it is not defined. So right side of 3 pi by 2, it will be like this, 2 pi. The same portion, this part continues in right side as well as left side. For example, here it is going to be like this, then again like this the graph comes. From this graph also you can say the domain of secant function is all real number except odd multiples of pi by 2. Range, same logic, if you take the reciprocals of the numbers between -1 to 1 other than 0, automatically you will get the outputs from 1 to infinity, you see 1 to infinity or minus infinity to -1. Yes, that is the point. This is why the range is minus infinity to -1 union 1 to infinity, my dear friends. Now its graph, for your convenience I have taken a detailed graph. You see the same behavior you can observe. You see the dotted graph was cos x, the same cos x 0 to pi by 2, you see cos is between 0 to 1. So, the reciprocals took from 0 to infinity, and pi by 2 to pi cos is from -1 to 0. So, its reciprocal took from minus infinity to -1, right. So, in this way you can see the 6 graphs, my dear students. Yeah, yes, you see this. I have written, I have kept all the 6 graphs here for your reference. You must be able to draw a freehand rough graph of these trigonometric functions. Sine function, first to draw any graph of these 6 trigonometric function, first you take x axis, y axis, on x axis you plot the angles 0, pi by 2, pi, 3 pi by 2, like that. Then for sine function or cos function or secant or cosecant, better you take -1 and 1 on y axis. For tan and cot, those are not required. You see sine graph passing through origin, this smooth curve, wavy curve. Cos at 0 it is 1, mind it and draw this. Whereas cosecant x, same things, here this green part has become this part, you see same thing. Similarly secant x, and tan function, you see, which is an odd function, this is the graph that you can have in this, whereas cot moves a little ahead in first and second quadrant, it comes like this. Please do observe the difference of these, and for your reference, my dear students, I have listed the most important part, the 6 trigonometric functions, their domains and their ranges. So, friends, so you can also have note of these particular things, the functions, domain, range. Next, only one thing I need to say thank you. Before that, my dear friends, I mean to say, you see, in this class, this is a very basic fundamental class in which I try to give how to draw rough graphs of the 6 basic trigonometric functions. Undoubtedly, it is just a basic class, its extension, that means, so the functions with little transformed functions of these, like sin 2x, sin of x plus 3, sin of x plus pi by 6, 2 sin 3x, all these graphs I will take up in some other class. There I will explain in detail how to apply the transformations of graphs. My dear students, Infinity Learn is the platform where we discuss the contents basic level, higher level, in-depth level and advanced level. So, all of you, those who are watching, you just subscribe to Infinity Learn, and at the same time you please refer Infinity Learn to all your friends. So, we will continue a beautiful classes in course of time, right dear students. Thank you everybody, thank you very much.
sir.